Hello everyone, this is Physics 103 on atomic structure, and we are going to talk about the Zeeman effect. So, recall that we have discussed energy degeneracies in atoms, and in the hydrogen atom particularly, energy degeneracies arise when n, or the principal quantum number, is above 1. So let's take the case for n equals 1 first. So for n equals 1, we have L equals 0 and ML equals 0. So we only have the quantum state 1, 0, and 0 for n equals 1. Now for n equals above 1, say for example n equals 2, we would have two L values, or orbital angular momentum values. We have L equals 0 and L equals 1. So L equals 0 can only have value of ML equals 0, but L equals 1 will have three values for ML. So we have minus 1, 0, and what's this? Positive 1. So we have actually how many states? 1, 2, 3, and 4. So we have 4 states associated with n equals 2. So recall that energy in a hydrogen atom is only dictated by the quantum number n. So for those 4 states, let's list them down: 2, 0, 0, 2, 1, negative 1, 2, 1, 0, and 2, 1, 1. All of these will have energy that is equal to minus 13.6 eV over 2 square, or n square. So they're all energy degenerate. So what is Zeeman effect? So Zeeman effect has something to do, or it has something to do with messing up these energy degeneracies. So Zeeman effect just a brief introduction. It is discovered by Dutch physicist Pieter Zeeman. So he's Dutch physicist, and upon his discovery, he observed that when you pass a gas, say for example hydrogen gas, to an area with an external magnetic field B, he observed that some spectral lines of the gas were, let's zoom that in, we're splitting into different values. Okay, so this is contrary to what should be observed in energy degeneracies here. So when you have a certain energy degenerate value for say a certain frequency of light, this should only give one spectral line. But he observed that for some values they were actually splitting. So Peter Zeeman observed that on n states greater than 1, when the quantum state is has a value for ml, meaning that for example -1, 0, and 1, it will the spectral lines are splitting. Okay, so why is that so? So let's have an energy in the y-axis, and let's say here we have n equals 1, and here we have n equals 2. So for n equals 2, for the state L equals 1, this actually has ml equals -1, 0, and 1. So this ml, if you would recall, has something to do with the z component of the angular momentum. So this z component of angular momentum provides a magnetic moment to the electron. So when the electron actually sort of orbits the proton in a certain manner with respect to the z component, so this is our electron, it will tend to align with respect to the external magnetic field B. So when that electron aligns or it doesn't align, its potential energy or its energy will be different. So that is why at n equals 2 states where there is a presence of a magnetic moment, the spectral lines are splitting. So for example, in n equals 2 states, we have here ml equals -1, ml equals 0, and ml equals 1. So there are 3 states that are split in the n equals 2 state, as opposed to the energy degenerate behavior. So this is the Zeeman effect. Simply put, the Zeeman effect is just splitting of spectral lines due to the magnetic moments that arise from the orbital angular momentum.